Hello, Matthews Gatos here. In this video, we're going to look at perfect squares. Let's get started. So a perfect square is a number that has two identical factors. So if something has two identical factors, it's a perfect square. Rational numbers in fraction form are perfect squares. So rationals are perfect squares if the numerator and the denominator are both perfect squares. They don't have to be the same number. Rational numbers in decimal form are perfect squares if after you change the decimal to fraction form, the numerator and denominator are both perfect squares. So I just want to let you see what the first couple perfect squares look like. Okay, so if I were to list all of the perfect squares out, just the first 20, these are my first 20 perfect squares because these numbers are the main number on a diagonal that has identical factors. So for example, 64 is a perfect square because it's 8 times 8. 289 is a perfect square because it's 17 times 17. So perfect squares, again, two identical factors. So let's try an example. I want to determine whether 25 over 49 is a perfect square. So what I want to know is, can I write the numerator as the product of two perfect squares? So 25 I know is 5 times 5. 49 I know is 7 times 7. So since these two factors are identical, that means that 25 over 49 is a perfect square. So it is a perfect square. Let's try another one, 0.4. Now, I want to write that as a fraction, so I'm going to use place value. So the first thing I do is ignore the decimal and write the number in the numerator, which would be 4. Then I look at the place value. So one number after the decimal place is my tenths value. So 0.4 is the same as 4 tenths. So I want to know, can I write 4 tenths as two identical factors? So in the numerator 4, I know I can write that as 2 times 2. That's a perfect square. But in the denominator, 10 is 1 times 10. Those aren't identical. Or 2 times 5. Those also aren't identical. So when I look at these factors here, they are not identical. So even though the numerator was a perfect square, denominators have to be as well. So that means that 0.4 is not a perfect square. So again, perfect squares, two identical factors. Okay, I want you to pause the video, try these 3 questions, and then come back and compare your answers and see how you did. Okay, in the first one, 121 over 64. So 121 can be written as 11 times 11. 64 can be written as 8 times 8. So since these two are identical factors, that tells me that 121 over 64 is a perfect square. Let's look at the next one. Okay, for this one, 1.2. So again, ignore the decimal, and I want you to write that as 12 over one number after the decimal place has a place value of tenths. So 1.2 is the same as 12 tenths. So in the numerator, 12, I could write that as 1 times 12, not identical, 2 times 6, not identical, or 3 times 4. So you can see there is no combination. Same thing in the denominator, 10 is 1 times 10, not identical, or 2 times 5, also not identical. So since these two numbers are not identical factors, I know that 1.2 is not a perfect square. Let's look at our last example. Now, last example, 0.09. So ignore the decimal in the zeros, and the numerator would be 9. And then in the denominator, remember this was tenths. Well, the next one is hundredths. So 0.09 is the same as 9 over 100. Let's see if we can write that as a perfect square. So I know that 9 is 3 times 3. Those are identical. 100 is 10 times 10. Ooh, also identical. So since these two factors are in fact identical, that tells me that 0.09 is a perfect square. So I hope this video on perfect squares helped you, and I look forward to seeing you for the next one.